Good morning, my algebros. As we head into chapter 7, it will all be about factoring. Factoring. What exactly is factoring? Well, factoring are the things that you would need to multiply to get a product. It's kind of the reverse of multiplication. You're looking at what things multiplied to have a product. For example, if I have 20, the things that make up 20 are 20 times 1 and 4 times 5 or 2 times 10. These are all factors, right? This is a factor of the number 20. Just to kind of give you that little warm up of what they are. So how do we find the greatest common factor of monomials? Well, first we're just going to talk about prime factorization. Prime is a number that cannot be factored any longer, like the number 1. There's some natural terms that just are never factorable, and we want to get all of these numbers to be only prime numbers. And one of the ways we can do this is using a factor tree. If I start with 60 and I just can factor something off and I look at the things that multiply to equal 60, and the easiest way to do this is just divide by 2. So 2 times 30 is 60, and then 2 is a prime number. So we're done on that side of the tree. 30 can be divided by 2, and it's 2 times 15. Again, 2 is a prime number, so we're done. But 15 is 3 times 5. 3 is prime and 5 is prime. And now we have got it down to prime factorization. So we know that if I have 2 2s and a 3 and a 5, when we multiply these all together, that would be 60. All these prime numbers multiplied would be 60. And then, of course, because we know exponents, we would write this in exponential form. So 2 to the second times 3 times 5. And now I've gotten to prime factorization. If I have 72, let's just practice this a little bit. Well, that's 2 times 36. And we know 2 is prime. And then 36 is 2 times 18, and again, we know 2 is prime, and 18 is 2 times 9. Again, 2 is prime, and then 9 is 3 times 3. So with this, we would end up with 3 2s and 2 3s, or 2 to the third power times 3 to the second. Now, is there a faster way to do prime factorization? Well, of course there is, because I don't need to just keep dividing off a 2. I know that 72 is also just 9 times 8. And we have used 2 to the third power equaling 8 over and over and over again in chapter 6. So hopefully that's very recognizable. But if not, that's okay. And we know that 9 is 2 3s, and 8, if we just took off a 2, then we'd have 2 times 4. And we know 4 is just 2 times 2. So again, this is just a quicker way to get to our prime factorization, but both ways are fine. Both ways are fine. The tree on the last one is just a little bit shorter journey. And you know me, I like shortcuts. Go ahead and try this one and see how you do. Please find the prime factorization of 40. Pause the video here if you're watching it from home. Okay, let's check it. Let's see. Did you get 2 to the third power times 5? And if I did the long way, it would look like this. If I did the short way, I'd do 5 times 8, and 8 is just 2 to the third power. Much faster, right? Now, why are we learning prime factorization? Because it's good to know the things that make up numbers so that we can find things that are in common of 2 different numbers. We call this common factors, right? If I look at the common factors of 24 and 60, well, I could list them all out, right? the first method would be to list them all out. And I know that 24 is 1 times 24, 2 times 12, 3 times 8, 4 times 6, right? There's no more. On 60, I know that it's 1 times 60 and 2 times 30 and 3 times 20 and 4 times 15 and 5 times 12. And now and of course 6 times 10. I can look at what they have in common, the largest things they have in common, right? Greatest means big, great. What's common is the same. And factor, well, we just talked about those numbers that multiply to equal a number. So the GCF, or greatest common factor, and these are going to be 12. It's 12. It's the largest number, the largest factor that they have in common. The second method would be to use prime factorization, right? And if I do the prime factorization of 24, I know I'm going to end up with 2 to the third power times 3. And with 60, I'm going to end up with 2 to the second power times 3 times 5. So what they have in common are 2s and 3s, right? So our greatest common factor would be the multiplication of these, right? 2 times 2 times 3, which is 12, which we know is our greatest common factor. Go ahead and try finding the GCF of 18 and 36 and use whatever method you want. One thing I noticed that sometimes if you have very solid multiplication tables and you can see multiplication pretty well in your head, you can do these very quickly. So for this, it's obviously going to be 18, right? And that's one thing to check too. If I have one factor and if I know it's just double or triple or quadruple to equal the second factor, I should always try that first. All right, let's talk about finding the greatest common factor of monomials now. So we don't need to get nervous about these because we know that finding actually the greatest common factor with whole numbers is actually harder than finding with exponents, right? Because our exponent rules are just subtraction and adding. So we know here if I look at 3 times x to the third power, that's going to be a 3. And a 6 is just going to be a 6, right? And a 3. And then I have x to the third power is 3 x's and x to the second power is 2 x's. So obviously what they have in common is a 3 and 2 of the x's. So the greatest common factor will be 3x squared. Because that's what they have in common and the largest that they have in common. Let's look at it again. If I have these two monomials, what would they have in common? Well, I first deal with the whole numbers, and I know that 12 is going to be 3 times 4, and 40 is going to be 4 times 10, and 12 doesn't go into 40, so the greatest whole number is going to be 4. And then I know they both have 2 x's, and they both have 2 y's. That's our shortcut. Okay, let's see if we can do 3 monomials, right? We have 16, 24, and 40. Well, we already know that 12 and 40 have 4 in common. We know that 24 and 40 would also have 4 in common. And we have the 16 over here. Is there a number larger that we can multiply? We start to think about our factors in 16. We know it's 2 times 8. Can 8 go into 24? Can 8 go into 40? And they can. So we know that 8 is going to be the whole number. And then what's the largest amount of A values that they have in common? Well, just one, right? And what's the largest number of B's that they have in common? And that would be 2. And there you have it. So let's find the greatest common factor of these two, right? What would be the greatest common factor between 4 and 5? Yeah, these are prime, right? They're prime numbers, so it would only be 1. And neither of them have x's and y's, so we know that the greatest common factors is just literally just going to be 1, right? Go ahead and try finding the GCF for these two terms, please. Pause the video here, and then we'll see how you did. So when I think through these things, I think 18 is 9 times 2. That's the largest ones. And 9 goes into 27, so I know 9 is going to be the largest whole number. And then they both have 2 g's. So 9g squared. So why do we care about all this? Because when we simplify something that looks like this, we can see that 2 can be divided into both of these. Because what this fraction actually is 4x divided by 2 plus 2 divided by 2. And if I simplify this, I know that I can reduce 4 over 2x to 2x, and 2 divided by 2 is 1. So we're just simplifying here by dividing. Let's try this one, a little bit more complicated. So remember, I need to see them as separate fractions, because whatever I do with the 6ab, I have to do to every term in the family. When we distribute multiplying it to everything, but here we're dividing to everybody in the family upstairs, right? So I need to see them as separate a little bit. So 12 divided by 6 is going to be 2, and then I use my exponent rules. A squared minus 1 is just a, and b divided by b is 1. So I know that I'll get b to the 0 power, which is just 1. So I'll have 2a. And then I have 24 divided by 6 is 4. A divided by a is to the 1 minus 1 is 0. So that's just 1 whole number. And then 2 minus 1 is 1. So b to the first. So then 4b. Okay, today's homework is going to be the puzzle, 7-1 puzzle that is on Learn. And then you're going to be doing some textbook problems as well. Alrighty, I will see you next time.